Hello again, welcome back to another episode of Mr. Walker's Chemistry. Today we'll be talking about neutrons, another subatomic particle, part of atoms. Okay, so in previous videos we have learned about an atom and we just introduced it and said that an atom contains three subatomic particles, the protons, the neutrons, and the electrons. In another video I talked about the protons. So in this video we're going to talk about the neutrons. What do we know about them? What are they used for? As a reminder, we have this diagram here, and you can see that you've got protons and neutrons in the middle, which we call the nucleus, and around it are the electrons, which we will go into more depth about later. Okay? So what should you learn by watching this video? Well, by the end of the video, I would like for you to be able to explain what a neutron is. Okay, so if somebody asks you, what is a neutron? Be able to answer that question. And then, of course, how do we apply the information about neutrons to chemistry? How do we use that information? So, what is a neutron? Okay, the most basic definition of a neutron is that it is a subatomic particle that is in the nucleus with a neutral charge. Okay, so what does that mean? Well, subatomic, okay, means smaller than an atom. All right, so here is an atom, and you can see it's got the same basic configuration of all the pictures of atoms you've seen, where you've got electrons going around the nucleus, and in the nucleus you have protons and neutrons. All right, so they are in the middle, they are smaller than the atom. Everything together, this whole picture is an atom, so just this is a neutron. All right, and they have a neutral charge. Neutral charge means that they don't have a positive or a negative. They have a charge of what we just write as 0. Okay, they have no charge, meaning they don't conduct. They're not part of electricity. If you put a magnet near them, they're not going to. The magnet will have no effect. It's just neutral, no charge. Okay. And of course they are very tiny. They have the exact same mass as a proton in terms of grams. All right, and because this is such a really small number, okay, I think in a previous video I typed it out, you have 23 zeros in front of this 1. That's how small this is in terms of grams. Okay, this is a very, very small particle. All right, so because of that small measurement, it was much easier for scientists to just invent their own new measurement that was equivalent. And so they created what they called the atomic mass unit, okay, or AMU for short. All right. And a neutron weighs the same as a proton, which is 1 AMU. All right. So going back to our original question, what is a neutron? Okay, that's our topic up here. All right, it's a subatomic particle in the nucleus with a neutral charge that weighs 1 atomic mass unit. All right, that is your important information. You should know all of that information. All right, and also be able to pick it out in a diagram. All right, I always have diagrams. So in this diagram, if I were to give this to you in a quiz or a test, or even just, if somebody came up to you on the street and asked you, hey, what's this a picture of? You should be able to tell them it's an atom, and these are the protons, neutrons, and electrons. So what does a neutron tell us? What is it useful for? All right, neutrons are primarily used to find the mass of an element. All right, this is different than the protons or the electrons. Protons, as a reminder, are used to find what type of element it is. So if you have 1 proton, then it is hydrogen. If you have 2, it is helium, and so on. All right. Now, while protons contribute to the mass, they're only part of it. So we use the neutrons to figure out the rest. So we know if we have carbon, for example, let's go with carbon here. All right. So we have carbon. It's abbreviated with C. It has 6 protons. Well, we know that that will be a mass of 6 AMU. So then with the neutrons, we can figure out the rest. If we know our entire atom weighs 12 AMU for the whole atom, then that means that the neutrons half 2, there's the abbreviation for neutron, just an N with a 0, must equal 6 AMU as well. Alright, we're going to do lots of practice with these sorts of things to make sure that you guys really understand what we're talking about here. Alright, but I do have an example here in the text. With this picture here, this diagram here, we see that it has 2 protons, the blue ones. So I'm just going to draw in some P's here for protons. Okay, those are my protons. And then I've got neutrons as well. And so these are my red spheres, so I'm just going to put little N's on top of those. Alright, so protons and neutrons here. So it means that it's helium because we have 2 protons. And helium is number 2 on the periodic table. Alright, so they are giving the mass of 2. Helium has a total mass of 4, so that means we have 2 neutrons. Alright, we're going to do lots of practice with these. This is the only real math that you will need to do with neutrons, is figuring out what is the mass and is it a little bit different. Okay, so another way to think about this, instead of kind of working in reverse. Alright, if I tell you have an oxygen atom, which is O on the periodic table, that's the abbreviation, that's the symbol, alright, we can find that it is number 8. And it has a total mass of 16 AMU. So can we figure out how many neutrons it has? Well, surely we can do that. Okay, so we know the total mass is 16. That's told in the problem. We also know that it will have an atomic number of 8. Remember that atomic number equals the number of protons. So I'm going to put atomic number equals number of protons, P plus for proton. Okay, well, now with knowing that I have 8 protons, we can convert that to a mass and say we have 8 AMU from our protons. Simple enough. Well, if I have a total of 16 and only protons and neutrons contribute weight to the atom, then I know that I must have X number of neutrons, and they must add up to 16 total. So in this case, X equals 8. Okay? So again, we'll do more practice with these. Alright. So here's some more practice, and here's the periodic table to help you out. So we've got a periodic table. Remember to always look at the key to find out what information is where. Alright, so using the periodic table, identify the mass of an element with 15 protons and 19 neutrons. Alright, let's figure out what element that is. So 15 protons. Well, atomic number equals number of protons. So right here we can tell that we have phosphorus. So we're going to draw in a P here for phosphorus because that's the symbol that we have here. Alright. So that's from my 15 protons. That's where that came from. Now it has 19 neutrons. Alright, so protons plus neutrons equals the mass. It's pretty simple. Okay, so protons plus neutrons is the mass. So 15 plus 19. So I can put a little 15 up here, because that's my atomic symbol. And then I'm going to figure out the mass. So 15 plus 19 is going to be 34. So phosphorus will have a mass of 34 in this case. Now this is a little bit different than what's on the periodic table, but that's okay. Alright, remember we're using the number of neutrons to find the mass, not always what's listed on the periodic table. So go ahead and try a couple of these others. Alright, so if it has 12 protons, 12 neutrons, how much does it weigh? What element is it? Same thing for this one. Alright, so let's look at this fourth one here. What is the mass of the neutrons in carbon? Well, let's go to our periodic table here. Let's grab some information from it. So we have carbon, so we're going to look for carbon on here, and there it is. We can see that it is number 6. So we know it has 6 protons. And its total mass, we're going to round a little bit, is 12. So if I have 6 protons, the mass is 12. Let's plug into our formula. So 12 equals 6 plus x, our unknown. So the mass of the neutrons will be our unknown. 12 equals 6 plus x. Well, I think most people could do this in their head, and they'll find that x equals 6. Alright? Simple enough. So do the same thing here for iodine. Try that one on your own. You should be able to do these math problems in class and on a quiz or a test that I give you. Remember how to use the periodic table. Remember to look at the symbol to find where the number is, where the mass is, and the name and symbol. So here is a review for you guys. What is a neutron? Be able to answer that. That's one of our objectives, is that you can define what a neutron is. So in this case, a neutron, again, a subatomic particle that has a neutral charge, and it weighs 1 AMU. Okay. They are located in the nucleus. As I said earlier, neutral charge, it weighs 1 AMU. Right? That's all the important information. That is all kind of the definition here. All right? And what is the number of neutrons used for? Primarily, it's used to do very simple arithmetic to find out the overall total mass of an atom, because we will often know how many protons it has and how much the whole thing weighs, but not necessarily the number of neutrons, which we can find out with that information. So please go back, find out, review anything that you missed or may not have gotten the first time through. I hope that you learned something, and I'll see you next time.